Okay, so as we discuss yesterday's session, the basic statistics about the introductions of statistics, then we talk about the different tests, and then we talk about the classifications of statistics and different other things. uh, Now the things is that even we have gone through the research hypothesis and research design. We have tried to do some practical exercise, but it was very short time because we have to finish the introduction part. So today we'll try to do more exercise in R. So we'll have half an hour, some few basic of the regression and non-parametric test and correlations. Then we'll go to directly to the programming language in R. So we can spend more time on the exercise, and I hope everybody till now it's get the basic idea about the statistics, the t-test, the ANOVA, the parametric, non-parametric. We'll discuss today in more details. And as I told you that each and everything will be shared. So today at the end of this session, I will share the link in Google Drive that will have the all the PPT presentations along with the code and also the data. The data, all the data are dummy data. Okay, so used in the whole exercise, I will share that all the Excel, but all the data are dummy data. Okay, so there is no means it's a dummy variable for this all the data in Excel files. And another thing regarding the certificate, I told you that it will take time because it need to be sorted out the attendance sheet. After the sorting out, we will prepare the certificate. So it will take some time, 10-15 days you will receive. And yesterday's session, I think it is already available. I have uploaded the yesterday session in YouTube. I will share you the link in the chat box, and yes, I can share it now also. And then another thing is that just let me copy this one. It's a link copied. And also we are preparing a just very small, only your name and email ID for to prepare the certificate, because some of the time during the registration process your names are in not in proper format, some of them are don't fill in properly, so it's very difficult to get the proper name. So that's why we will share a link that will be basically you have to fill your name only on that link, and to prepare the errorless certificate. This is the things. And another things, as I already mentioned you in the yesterday's session, that it's a free course, but if you are willing to donate, you are welcome. I have already shared the link or the account details to sharing the donations, that is shared in your email. So you can share the amount, or you can whatever it is you can donate in the you will find in your email. So here is the link for the YouTube link for the yesterday's session, and today's session when I'll prepare the whole video I will upload also. Okay, so regarding till now, is there any questions or any clarifications? No. If not, then we'll start the first half an hour. We'll finish the Q2 3 theoretical part. Then we'll do the practical exercise. Okay. Okay, so yesterday we have discussed the basic statistics or the descriptive statistics a lot. We have discussed that mean, median, mode, kurtosis, skewness, then the box plot. Then we have discussed the means histogram, different things we have discussed, and we several time I have mentioned that the data normality, data distributions. So as you also know how to figure out the distributions of the data, just like you can make a of superior test, you can prepare a box plot. From the box plot also you can say whether it is, but to sure from the graphical, it sometimes it's difficult to identify that whether your data is normal or non-normal. So for the particular test you can do the Saphiro test. So Saphiro test is it's tell you that whether your data is normal and non-normal. So why this thing is required, we have discussed yesterday. So today I'll tell you some of the things is important for the parametric and non-parametric test. So what is the non-parametric test? It's basically whenever you have a data that is not normally distributed, which is this is the skewed data, or either a positive skewed or negative skewed, or either or maybe the data is ordinal data. We have discussed yesterday that ordinal data, nominal data, continuous data, different types of data we have discussed. So data is ordinal data, and as I told you, the distribution is not normal. Then you can do go for a non-parametric test. So what are the non-parametric test? Basically, first I told you that you have to check the normality, then you can choose the proper test. Okay, so for t-test we are doing for parametric data, means a parametric test is a t-test, means when your data is normally distributed. Okay, whenever your data is skewed data, at that time you have to go for a mean Whitney test, that is independent t-test. I have discussed the independent, dependent, paired, unpaired t-test, one sample, and repeated measure ANOVA in yesterday session, even correlation regression also. So in case of paired t-test, that is if it is your data is normal, then you can go for a paired t-test. If your data is not normal, then you can go for a Wilcoxon test. Okay. In case of ANOVA, one-way ANOVA, instead of one-way ANOVA, you can do a Kruskal-Wallis test. Okay, so that is the non-parametric test. In case of repeated measure ANOVA or two-way ANOVA, you have to do a Friedman test. Okay, and Pearson correlations we have discussed even yesterday. That Sparkman-Frank correlations is the non-parametric test, and linear regressions, that is the Gaussian distributions. Whenever data is your Poisson distribution, then you have to go for different other non-parametric linear regressions. Non-linear regressions we'll discuss in furthermore. We have also talked about in yesterday session that whenever your data is pre-predator dynamic data, pre-predator relationship, then the length-word relationship in peace, that all the relationship is basically non-linear relationship. Okay, so this is the different types of paired test you can go for like this, and on the other hand you can go for different types of non-parametric test. So first, data normality is very essential, then you can choose your particular test. Yes, I already told you for parametric or the for parametric or normal distributions, you have to go through the mean, but non-parametric or skewed data, you have to find out the median. Okay, not the mean. So non-parametric test, basically the median base. And what are the tests? I have already mentioned. This is here one of the short table mention the same thing. Now, why you have to use parametric and non-parametric already explained very well. No need to repeat more. Go through it. I'll share all the presentations. Parametric test, yes, number of samples will be less, number of samples will be high, then you have to do this test, this test. These are the very basic things, no need to explain more. So one way and over, you have a 20 up to 20, it's okay. More than greater than 20, then you have to think about other tests. So normality test, I already distributed the test yesterday, that there is a different test is there, but Sapiro test is very common and widely used and widely acceptable test, Sapiro test. Okay, So you have to see the whether your data is basically Gaussian distributions or it could be a Poisson distributions. Gaussian distribution is a normal and Poisson distribution is non-normal. So then graphically you can see the box plot. One of the graphical presentations is the box plot. One of the graphical presentations is the histogram. Also one of the graphical presentations of histogram to find out the basic structure of the data, shape of the data. And also you can see the QQ norms or QQ line as we have seen yesterday session. So that can also tells you whether your data is normally distributed or not. And different statistical test is there. WS test, Jacob Vera test, Sapiro test, that is very common and widely accepted. So that's why you are using Sapiro test, but you can use any test to check the data normality. So this is the QQ plot and QQ line. So this is the normal data and this is a non-normal data. Okay. And what is the hypothesis for the Sapiro test or any normality test? So you will find out that your null hypothesis basically is tells that your data is normally are not significant difference that the normal distributions. Okay, and alternative hypothesis is tells you it is a different than a normal. It's a non-normal distributions. Okay, so whenever up in Sapiro test, you will get your probability value is if you received your probability value just as greater than 0.05. So greater than 0.05, that means it's a normally distributed. At that time, you have to accept your null hypothesis. That tells you your data is normally distributed. In Sapiro test, if you get after the test, if you received your probability value is less than 0.05, means you have to reject your null. So you have to reject your null and you have to accept your alternative hypothesis. That is tells you your data is non-normal distributions. Okay, so that is the hypothesis for Sapiro test. Now there is a different statistical or the R package out there. We have discussed dplyr yesterday. We have ggplot is very good to visualizations. There is a different other packages that can be used to estimate the different things. So ggplot, qqplot, qqline, we have this, and Sapiro test is the three easy way to figure out the data normality. Then non-normal few test, Wilcoxon test, very simple. You just type down Wilcox.test. Okay, X and Y, if your data is paired, so just write down paired is equal to true. Okay, and a non-paired data, you have to say paired is equal to false. So non-paired data, you have to do a Min-Whitney test. Okay, that is obviously Wilcoxon test, but your paired is equal to basically false. Then Kruskal-Wallis test, that is basically instead of one sample t-test, so no, sorry, one means one-way ANOVA. Whenever you have three sample, so then you can use the Kruskal-Wallis test instead of doing the one-way ANOVA. And if you have a two-way ANOVA or repeated measure ANOVA, then you can go for a Friedman test. Okay, so these are the very simple. Just save that first table that I mentioned, all the dependent means parametric and non-parametric test. So these tables will tells you everything. Yes, if you remember this one, so whenever you are doing first check the normality, then choose the test, then choose the you have to do a t-test or ANOVA, then choose whether it is Min-Whitney or normal independent t-test or dependent t-test or Wilcoxon. So choose it. Okay, so this is the basically non-parametric test. We will see some of the non-parametric test in your data in our exercise. Now, correlations I have already explained, so no need to go into the deep of the correlation, but few things I will explain. Very simple. It's we know that correlations have a positive and negative. That's basically tells you the R value. It basically lies between -1 to +1, and 0 means there is no relationship. Plus positive, it will goes to 1. so that will be high relationship between the variable, and if it is also minus high, that is also negative high correlations. Okay, so that are the very simple. So there is a strong correlations, no linear relationship. If you drag down the line, so it will be almost same, r is equal to almost to 0, and strong negative relationship is that one, so that we all knows. So these are the few tables that relationship, and then we can say that whether it is strong, weak, moderate, or very strong. But very importantly, I told you yesterday also that this r value is not sometimes statistically significant. So after those r value, you have to do a test of significance, so that can be used, make a statistically valid that yes, my relationship between these two variable is significantly correlated. Okay, so then you have to do the probability value. So hypothesis is, you know that there is no relationship between variable. Alternative hypothesis, there is a relationship between these two variable. We have discussed one example in Hilsa, fish, catch, and salinity. Uh, so yes, there is also left tail, right tail, and two tail. This is very simple. Left tail means it's a negative correlations. Right tail means as a positive correlations, and two tail means I don't know whether it is positive or negative correlations. So t-test, after doing the, this is the r, how you, so this is the basically simple equations how you calculate the r is equal to nothing, sum of data minus mean of that data, and y minus y bar. So these are the two variable, x minus x bar the square, and sum of the square root of the whole things, and sum of y minus y bar square. So you can calculate the r. After getting the r, you have to do a t-test. That t-test tells you whether your r is statistically significant or not. So the t-test is equal to nothing, r into square root of n minus 2 by 1 minus r square. Okay, so this you will get the t value, and also you will get the probability value. So that can be put it after the r square, or r, sorry. Pearson correlation, as I told you, this is for the normal distributions. If you have Pearson correlation equation is this one, and no need to remember the equation, but I just put it here, the type of equations. And non-parametric correlations, permanent correlations, that is basically used for rank correlation or non-normal or ordinal data. Not ordinal, that is basically nominal data. And Sparkman rank correlation used for yes, to find out the rank between the variables. So this is the equations for Sparkman rank correlations, and t-test equations are the same. So this is the correlations. Very simple, no need to, it's everybody know about the correlations, it's very simple. But regression is little bit important, and you can do very regression good model you can develop, and it can also, as I told you, the correlation is find out the relationship between the variable, and regression is also find out the, along with the relationship you will find out the predictions. So you can predict your y inputting the x value. So as we discussed yesterday, that ice cream sale and temperature. So here basically the association between these two variable, one is the dependent, one is the independent. As I told you, ice cream sale is dependent on the temperature. So one is dependent variable, one is the independent variable, and one will be predicted by using the other variable. So if I tell you the temperature, you can predict the ice cream sale. And that is the most important thing. I'll tell you a few minutes after. So then most important thing is the residual. Residual is nothing. So we are plotting after the xy plot, or the basically a regression line. So what is the error or residual? That is means basically also error. How the far your data from this line. So regression line, each and every data, how it is far from the your line. So that is basically called a residual, and or maybe the error. So how far is the errors or the residuals will be very far. Your relationship or your basically regression will not be strong. If in case of regressions, we will basically getting the r square value. but in case of correlation we are getting the R value. So what is R square value? It is very important to understand the R square value. Suppose I give you the one example, that ice cream cell and temperature. So if from this ice cream cell and temperature, if I get the R square, suppose if I get R square is 0.82. so what does it mean? R square is 0.82. What does it mean? Okay, R square is always values from 0 to 1. Okay, because it is the square of R, so it's no negative values. Okay, so what does it mean? It's very important. So it's mean that from these regression equations, I can predict the ice cream cell, and my predictions is 82%. My prediction is 82% uh, success. Okay, if 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 the ice cream cell is this much, if the temperature will be this much, ice cream cell will be this much, that 82% time I am sure the predictions will be valid. Okay, if my R square value is suppose 0.99, so that means almost 100%, almost 100%, or 99%, I am sure that my predictions, if the temperature is 32, 100%, the ice cream cell will be 150. Okay, so from the regression line you can calculate the predictions. Okay, so you know that I'll tell you in the next slide. So regression is, we know the simple regression and multiple regressions is, we have two variable, and if you add more variable, that is multiple regressions. So in a regression equations, we have this very simple equations: y is equal to mx plus c, or basically we are telling y is equal to alpha plus beta into x. So y is basically my dependent variable, that is my ice cream cell. Okay, so that is my ice cream cell, and intercept and slope, and this is my dependent variable, this is the temperature. So if I tell you the temperature, the today's temperature is this much, so you can predict the ice cream cell, and after these equations you can find out the R square value. So if the I square value is, again I'm telling that if it is 0.99, so that means 99% I'm sure that I can predict that ice cream cell. 100% sure, mean 99% sure. If the temperature is 32°, then ice cream cell will be 150 per day from this stall. Okay, so that means is the R square. Okay, I hope you got it. Now that the y is equal to mx plus c, what is slope, what is intercept? That's a very simple. Slope is the angle from this data to the line, and y is the change in x to y. So intercept is, if I change x, or if I change so each and every x have a representative of y value. So each and every x has a representative of y value. So how much is x is changing, means if I change x from here to here, how much is y is changing. Okay, so that is called basically the slope, change is y and change in x. And how your means, if intercept is the where your x intercept in the y. So if you drag the line, at what value y will be intercept the x. Okay, so that is basically the intercept and the slope of a regression equations. So these are the simple some of the equations, no need to remember, just you can say that what is regression line, what is intercept, and what is slope. So intercept equations and slope equations are given here. R square, it's a regression sum of square and total sum of square. And so standard error, so then after that you can calculate the standard error, slope, everything. So as I told you, that residual, it's very important. So if the low residual means your relationship is very strong. Then you the same things at the like the t-test, like the correlations here is also, after the regressions is also you have to do a t-test, and that is very important. My regression line, I got my regressions equations, but I got my regression equations, but I received that my regression probability value of this regression test is greater than 0.5. So statistically, basically this regression is not significant. So if you try to predict in a insignificant relationship, that will be wrong. Okay, so whenever your regression statistics, a regressions line or regression statistics is statistically valid or statistically significant, okay, at that time only you can use that regression for the predictions. Okay, and if it is not significant, it is not a good idea to use for this equation for a predictions. R and R square, I have already discussed that how much I can predict the y in terms of x. So what is the percentage of my it's mentioned here. Okay. So what is the hypothesis? I already told you there is a relationship or not, or null hypothesis and alternative hypothesis. Now, in a case of multiple regression, sometime we are find out that due to I have a suppose fish catch is dependent on the chlorophyll concentration, temperature, seawater temperature, and the nitrogen or maybe other variables. So I have a 3 4 variable regression line. Okay, so then I find out from this regression might be one parameters is basically make a noise in my regression equations, or it can make a problem that cannot gives significant of my regression. So at that time what you can do, you can omit that particular parameters. Suppose nitrogen is giving a problem, so you can delete this nitrogen from these equations, so you can find out a very good statistically significant equations. So sometimes you have to omit some of the means parameter or some of the variables from your regressions equations. It can be used. Okay. Multiple regression, as I told you, that's more than two. Now, yesterday we have already discussed, but telling the linear regressions and non-linear regressions. Linear regressions, we have a one linear, one dummy variable. Yes, sometimes we are using dummy variable, and interactions. Very interaction is very important. I tell you the what is interactions. Dummy variable, it's nothing. Just suppose male or female. So I put male is equal to 0, female is equal to 1. So I'm just putting instead of male, female, or yes or no, I put 0, 1. Okay, so that's called a dummy variable. I am putting some of the variable, a dummy variable. So 0 or 1, either or all. So that can be used a dummy variable for maybe Sparkman rank correlations or maybe kappa or pi correlations. Interactions, I'll tell you next. Interaction is also very important. It can be used different sectors. And non-linear, there is a different format of non-linear. It could be polynomial, square root, log format, reciprocal, or exponential. Okay, so these are the different non-linear formations of the regression line. So this is one of the example of a dummy variable or maybe a categorical data where I am using male female as a category, IQ and the score, and then so I have to use a Sparkman rank correlations in this data using dummy variable gender male 1010. Okay. And interaction, it is very important. Interaction effect, as I already discussed yesterday in the 2A ANOVA, that fish catch effect of particular fertilizer and the soil type, whatever it is. Okay, so same way. So interaction effect means it's both the factors are interact in the productions. Okay, suppose one example I'm telling you here is the suppose sales of Samsung phone. Sales of Samsung phone, it does not only depend on the quality of Samsung. Okay, it is also depend on the salesman. Okay, so this is the two things. So if the your product is also good, your salesman is also good, then your sales will be increased. Sometimes your product is good but your salesman is not good. Okay, so that productions or sales of that particular product could not be sold very quickly. So that is called the interaction. So both the things should be, suppose a productions of any agriculture crop, it depends on the fertilizer and also the soil quality, whatever it is. Okay, So both the things are when interact. So soil quality is also is a important factors, and fertilizer is also one of the important factors. So both the interactions having give you good productions, otherwise no. So these are the some example of the interaction effect. At the interaction we are making a multiplication symbols, we will see in the example in the exercise. When we are not using a interaction effect, just we will make the multiple variables as a plus symbols. Okay, so that we will do in the exercise sections. Some of the non-parametric log transformations. I told you some of the equations are basically non-parametric or basically non-linear regressions, just like preparator interactions, or some in fisheries we have using the length-weight relationship. So square root function is also there. Reciprocal transformations, exponential, one is increase, one decrease, just like preparator. So these are some of the regression statistics. Okay, so today I think this much of theory part. Then we'll do exercise one by one. I hope that yesterday we didn't make very good exercise because we don't have that much time. So today we'll go one by one, and after that I will share you all the codes and all the Excel file, so you can just first try that dummy data of my code using that one. Then you can try your own data to replace with your data and your code. Then you can find out means that all the codes are basically one time investment. So if you have the t-test or ANOVA anything, so you can how you can import your data on into that code, and then you can run and get your result. Okay, so we'll start the exercise. Before going to the exercise, if you have any questions or query, you are feel free.
Doctor,
Okay.
thank you for a
Yes.
nice presentation. By R, we can do wireless regression method
Yes. 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 Yes.
like that for one dependent variable and many of the independent
Yes.
variable.
Yes. 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 Yes.
Okay, next I will learn from you.
Okay. Okay. Any more questions?
Thank you so much, sir, for the session. Sir, I am an early career ethologist, sir.
Hmm.
Sir, can you share any package in R which have codes related to ethology?
Yes, yes, yes. I told you that in case of, because R is now it's a developing sector, and it's everything I can find out that from ecological standpoint, ethological standpoint, or environmental science. Each anyone can be only working in the pollution. So anyone is all only working in the populations dynamic. Anyone only working in the stock assessment. So each and everything have a package. Okay, so that you have to, I told you that self learning is the best learning. Okay, so if you are not finding anything, just search in Google, search in YouTube, you will find out everything. So all things are available in the web. If you don't find, then you need some help, then it's okay, but try to search for yourself in the web. That is the self learning is the best learning. Okay, so in ethology I sure there is a lot of package related to animal behavior or ethology. You can find out, search in Google. So our package and ethology will find out, obviously.
Thank you so much, sir.
Okay, any other questions? If not, then we'll start the session. Uh, I hope that most of you already installed R, and yes, yes. Any questions? Someone raise hand. Okay, so I hope that everyone installed R and R Studio. As yesterday session we have give you the basic of R and how to install it. I share the link, so you have to install R first, then you have to install R Studio. Then basics of R I have also tell, but it's I told you that it's a 1 or 2 hour lecture. It is not possible to teach or learn everything, but yes, you can start. You can start from now. So I will share that. Uh, one minute. Yes, so this is the last yesterday session. We could not finish the uh, good of way of the two-way ANOVA. I will explain it little bit again for today a little bit. Then we'll go to regression and correlations and also chi-square test. Okay, so first of all, I am again repeat this one, that how to import your data into R. So there is a lot of methodology to importing your data. You can read as a Excel file, you can read as a CSV file by coding, or you can directly import. On the right hand corner you have a import data set. From here you can import the txt file, you can import the Excel file, you can import SPSS file, SAS file, Stata file, anything you can import in the R platform. So that also one of the way to importing data from here, or you can directly read that Excel file by coding using that code. So you need to read the Excel file, you need a package that is called read Excel. Then you have to make a read Excel, you have to open that read Excel package by typing the library. Library is the what is within the package that will be unpacked. Okay, and then after that a simple code, you are just giving a assign your data into a name. So no need to type down the whole data into different types. So I am assigning X, Y, Z, whatever it is, you just assign of your data name, and then you type down read underscore Excel. That is the code how to read Excel. Then you have to give your path. I told you yesterday the path. Again I am showing you the path. Path is basically where your that particular Excel file is there. So how you get this Excel file, uh, let me open it as a 1 minute. Okay, so how you get your that path of your data file? Suppose my data is have in the desktop, so I am opening in the desktop on that particular file, and then I am going to that Excel file, that particular Excel. So how I get? I select that particular file, then I on the address bar, you will get the whole path of that particular file. Then you just click here, you will get all the whole path. Just copy this path. It is on C drive, user is .doctor, then desktop, statistical training, statistics, and lab exercise Excel. Okay, so this is the path of that particular Excel file. Just copy this path and paste in your here. Okay, okay, paste is here. uh, uh, Accept this data file name, accept this data file name, and then you have to change the backward slash to forward slash. So each and everything is backward slash. When you copied and pasted here, then you have to change each and every backward slash to forward slash. Okay, then you can write down your the data file name. So that is the ANOVA one way. .xls, this is the data file. So this way you can directly read that Excel file into your platform. So here I can this file is already read here. If you click, then if you view of this data file, just click it here and run. So run means it is you can see that each and every line will be run, will be it's starting. So if you view the data file here, we have seen that ANOVA test, one way ANOVA, there is a three different plant variety and their productions. Okay, so their productions. Then you run the whether that there is a significant differences in the productions of between these three varieties. We have run that ANOVA and we find out yes, there is a significant, and we can also plot the box plot of these three variety. Then we find out that mean value of these three plant productions is totally varies. Okay, so from box plot also you can tell you that there is a significant, but you need a proper test. So that is graphically you can say yes, but statistical test you have to do a ANOVA test, you have to get a probability value. So and that I told you that the here probability value is 0.0007, means it is almost 99.99% significant, means it is probability value less than 0.001. Okay, so it's a highly significant test that it tells you that there is a significant variations in productions of three different plant. Okay, now how you find out that where is the differences, then you have to do a post hoc test we have discussed yesterday. Then you can find out where is the differences, A or B, B or C, or A or C. Okay, that we have discussed. Now 2A ANOVA is also one of the good way. There is a, I told you, interaction effect. One is the things and one is the without interaction effect. We will see here. So interaction effect and non-interaction effect. So here is we have a data of 2A ANOVA. We'll see what is the data. Here is the data that is called that productions of the corn that's depend upon the variety or fertilizer. So I have a three variety of corn and I have a productions of this three variety, and I am using different fertilizer in that particular variety. I have using potassium, nitrogen and phosphorus into that particular variety. So whether the fertilizer or variety have a impact or means interactions or not, that we will find out. Okay, so if you go to this ANOVA test, the first model is to we'll do the box plot later on. So first model is that model 2 is telling that corn productions is impacted or is varies with different variety plus fertilizer. Whenever I put plus symbol means I am using no interactions. No interaction means I don't have any, it's not a repeated measure ANOVA. Okay, it's just a 2A one sample ANOVA, 2A not replicate. Okay, 2A ANOVA but no replicate. Okay, so then you can run this model, and then you can run the summary. My result is tells about here. In the down you will get the result. So you will find out that variety is also highly significant. So there is a significant variations into the three varieties, and also there is a highly significant in terms of fertilizer. So in fertilizer is also impacting on the productions of that particular crop. Now you can do a Tukey's HSG test. Where is which variety is good to find out? You can run a Tukey's HSG test, and you can which fertilizer is good, so that you can give this fertilizer or give this means promote this particular fertilizer or particular variety to the farmer, so that farmer can get a more productions. So that you can run a Tukey's HSG test and you will find out the result. And third model I am using a interactions. So this productions of corn is not only depend on the variety, it is also depend on the fertilizer. So both of the things are interactively related. So if I run this one, I will find out the result. Yes, the interaction you see in the third line, variety and fertilizer is also significantly impact. Okay, so both variety and fertilizer. So if you use that particular variety and particular fertilizer, you will get a very good result. Okay, so then which variety and which fertilizer, to find out, you can run a Tukey's HSG test here, and that will be very big because it have an interaction. It will interact to each and every one. So if I have a three variety, I have a four fertilizer, I have a three corn type. So each and everything will be varied. So variety one to fertilizer A, variety two to fertilizer B, variety three to fertilizer C. So each and everything. So C, corn B, calcium. So each and everything interacting, and then you will find out the p value, which is significant, which is non-significant. So you can find out that corn B calcium and corn A calcium not significant. So in case of corn A or B, you cannot use calcium. Is not a good variety with the calcium is. But if you use corn A nitrogen and corn A calcium, you can get a good result. Okay, so that is called a Tukey's HSG test and interaction effect in a to a repeated measure and above. Uh, then if you see the box plot also, I can show you also that. Yes, you can see that each and every variety and fertilizer, you can see that each and every variety and fertilizer are totally different. So that's why it is a significant different between all the variety and also between all the fertilizer. Okay, so this is a two-way ANOVA, and now we'll start correlations. Mm, and before that, if you have any questions, just let me know. Any questions? Let me. Yes, you can use both two keys and one penny. Both can be used. So that's the different techniques by introduced by different scientist or person. Okay, you can use two keys or you can use this one. It does not matter anything. Okay, so let me start the correlations. So just clean up this one. So correlations is single correlations and multiple correlations we will do. So first I have a multiple correlation. Yes, one question is there, I think. Yes, you can ask questions. Okay, so correlation is very basically that I told you that probability value is important. So from here, if you run a correlations, you will get directly the probability values. Okay, so let me start a data set. I have a I think I have a multiple data, but I can use both single and multiple as a single data set, no problem. So see the data here. So I have a data set of catch per unit effort, that is the basically the fish catch. So fish catch of I have a 12 no, 12 fish catch data, and I have maybe yes or yes, you can ask questions any who is. And then I have a different water quality parameters starting from pH, salinity, turbidity. So this data can be used in multiple correlations. We'll see that whether those parameters are having interaction between them, or catch is totally have any relationship between that particular multiple variables. So that can also be done on, or from this data also we can do a single one sample, single or correlations. That can be just one example. I'm telling that turbidity, that is basically the water clarity. So what turbidity is a value that tells you that whether water is dirty or not. Clarity of the water, it's depend totally opposite to the such depth. If the such depth is very low, means is water water clarity is not that good. So turbidity and satiety is basically always negatively correlated. So we can do one of the test. So here we will use that data. Then here is one of the things I am using a simple one data, that is the cord dot test, that is a correlation test. And then I am using the test between the fish catch, whether it is related with the chlorophyll or not. So if is usually we know that if the chlorophyll is increased in the water, seawater or any water, means there is a lot of phytoplankton, means there is a lot of zooplankton, means there is a lot of fish. So might be there is a relationship between chlorophyll and the catch. So that's a very simple. So if you run these two, then we will find out the result here in town. You will find out that yes, as the t value of this correlations value, first of all I'll check the correlation values is r value is 0.61. So it's yeah, it's a good correlations between the cpu or the catch and the chlorophyll, and that correlation is significant or not. So that's why I have to go that line. I have that will tells you that whether t test and the degrees of freedom, I have 11 variable, 11 numbers. So degrees of freedom minimum is 1, 10, and p value is 0.03, mean it is less than 0.05, means it is a significant, means your null hypothesis is rejected, alternative hypothesis is accepted. So there is a significant relationship between the fish catch and chlorophyll. Okay, and you can write down that there is a significant relationship between fish catch and chlorophyll. Within packet you write down your r value, r is equal to 0.61, and comma p value is less than 0.05. Okay, so this is the way how to write down a statistical interpretations of your results. Now we can do a multiple correlations at a single time. So there is a one way, there's a lot of way in correlations. You can find out very good graphical presentations. I'll show you one by one. So it's a one I have each parameters. Yes, if you are raising your hand you can answer, you can ask the questions. Yes, you can ask. Okay, so let me first finish this one, then I'll go for the questions for last 15-20 minutes. Okay. So here multiple correlations you can do. Just I have chosen 1 to 8 parameters. So very simple data, a simple code, core, comma data core. Data core is my data file. Core is my data file. I have assigned that data core of that multiple correlation, that data file, and data core of 1 to 8 variable. 1 to 8 means if you see the data, so 1 means is the catch, 2 is pH, 3 is salinity. So like this 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm just checking only 1 to 8. Okay, you can type down how many you have variables, so maybe 12 or 13, 12. Okay, so I'll see 1 to 8. I can run a correlation value. So here you will got a correlation matrix between each and every. So you find out here CPV is not significant correlated with pH, not significant correlated with salinity. There is a negative but not a correlated, but this is only tells you only the r value, not the p value. So whenever you want to get r value and p value at the same time, you have to run different other test or different graphical test. One by one I'll show you. So multiple correlations with p value. So each and every code, whenever you receive the code, find out that each and every code have its own title. Hatch multiple correlations with p value. So it's one sector. Then you can run different sector is here, different just graphical representations of this one. I'll show you one. Require this, and then just one chart. Yes, see here, this is one graphical representations of multiple correlations in one tables with probability value of significant. Okay, so I don't know this will be visible as a zoom, or let's make it figure. Okay, so here you can see that chlorophyll CPV is not a significant correlations with pH, but chlorophyll is not chlorophyll, sorry, CPV is correlated with 0.65, but significant with salinity, but non-significant with turbidity. No. Here is chlorophyll is highly correlated with the last one, that is silicate. Okay, so silicate is highly, and also it's 99.9%, or the probability value is 0.001. So that level, it's that CPV highly correlated with silicate. So what it means, its interpretation, that silicate is also one of the component of the phytoplankton. Most of the phytoplanktons are basically silicate. So that's why the silicate high means the phytoplankton high, means the catch is high. So here you can find out very strong correlations between, and significant also. So significant, it's tell you the star, and you can find out that here also turbidity is also negatively but significant correlated with turbidity with Sagittix. Okay, turbidity and Sagittix here 0.66. Okay, so that you can find out a multiple variable in a single plot. That's a very good representations for the research paper. And other format are also there. You can run one by one, you can find out different formats. So here is also, I think, core plot. You can run this one also, another format of, yes, another format of correlations. You can upper or lower, you can delete, or maybe this is the upper of the matrix and this part is the lower, or you can make the full, whatever it is. Okay, so there is a different format you can do, no problem. So here it's also all the correlation value, and whether it is significant or not in the scales, it can be. So different format is there to use multiple correlations, graphical presentations of multiple correlations. So then here is also one of the good plot structure is also, I think, yes, this is also another good plot of this same data, multiple correlations with probability, with the probability value, whether it is non-significant, ns non-significant, and star it is significant, and the different format of the star is also down there. So that's a very good representations of the multiple correlations in a single figure with statistical significant test. Okay, so this about the Pearson, all about the Pearson correlation. So down there, if you find out Kendall, I told you the Kendall correlations, Kappa correlations, Parkman rank correlations. Okay, so each and every thing is exercise is given with the hypothesis. If you read each and everything, I think you will find out that. Code and with there. So the Sparkman rank correlations is, as here is one of the example in math and English. 5 students, their marks, okay, in math and English. So you have to find out that that the student is means is there is basically a no association. The null hypothesis is telling that there is a no association between the math and English marks. Okay, so who is good in math, it does not matter that he is good in English. Okay, so this is the null hypothesis, but the alternative hypothesis is there is a association. Who is good in math is might be after the test you will get it. He is good not in English. Another is example I'm given here. It's a physics and math. So here you will, I think its data is telling that if the student is good in math, he must good in physics. Okay, so but it does not matter that the student is good in math, it should not be good in English. Okay, so that kind of a rank correlations you can find out that the among the 5 or among the list of the student, that who is ranked first, who is ranked second, and there is the interactions between his marks with the other subjects. So that is called rank correlations of Sparkman. And kappa correlation and Kendall correlation, as I told you, there is a it's basically a categorical variables. It's not a category. So based on which category, suppose one example given here, interview between the 12 candidates. So who is first, who is second, there is a, I have a, in the interview board there is a 4-5% interviewer is there. Their perspective is different based on their way how they are judge the candidate. So how to find out the who is the best candidate. Okay, so that is the way we can use a Kendall correlation to find out the best candidate among the all four or the two or three, whatever it is, interviewer, because each and everybody's perspective is different. Okay, so I'm giving 10 marks. So sometimes how you find out that I'm giving 10 marks to him, I'm giving 20 marks to him. So who's good? And another person is giving 20% of this one person and 10% of this one. So that's a totally different perspective will come. So that time we can use the candle tau correlation to find out who is the that both the have any interactions of both the interviewer or not. If not, then it's we have to choose the first or second in a different way. So these are the different types of correlation, all the type of correlations and all the formats of different graphical presentations you will find out in the whole code, and the data is also attached. You can try yourself one by one, run it, and then you can change your data. I told you that how to change your data, and also you have to change your variable name. My data is chlorophyll and catch. Your data is different, so you have to change the variable. So it's automatically it will come, because whenever you are attaching the data, I am attaching the data. If I type that suppose CPV of this one, it will automatically see CPVs of MT or kg, it automatically it will come. Okay, so you have to whenever you attach your data set, you can is everything will come, your variables will come. You have to know the name of the variable, just change it and try your data with that code. Code is one time investment, but you can modify it as far as your data set, and then you can enjoy the different test. Okay, so this about the correlations here. So if you have any questions, just let me know. There is a lot of comment in the chat box. uh, Between the cookies being fine, I told you. Yes, I told you several times. What is the good test for relationship to environment, temperature, and pulse? It's depend. It's depend upon. I told you that what is the good test. How to identify the good test. I have discussed yesterday. Yes, questions. You can talk. I think it's a mic is. You can unmute your mic and then you can talk. PCA, I told you this is a basically a 2 days training program. It's not. It's a basic course. Okay, so PCA, then NMDS, different other advanced statistics. It will need a different course. PCA is a different. Then you can go for NMDS or different other means multivariate statistics that can take a different course. Here we have discussed basically the basic statistics of t-test, ANOVA, regression, and correlations. Okay, any questions?
Yes, I have a question.
Yes, yes, yes.
Yes, I'm working on a project, so I'm looking at relationship between temperature, rainfall, humidity, and chlorophyll in regards to climate change impact. So, what
Hmm.
test will you advise that will be best to test for such a relationship?
uh, Actually, it's depend. I told you that you want to find out only the temperature, chlorophyll, this things, or something. Just like here I explained that catch. catch is my main research hypothesis was whether catch is totally dependent with this multiple variable or not, or any of the variable which is important. So you can go for a multivariate analysis, or you can go for a, that's the multiple regressions model. Regression model is also good, then you can find out that which one. So you can, regression models you can do step by step. First, that I tell you that here, just one example I already told you. So from my regression model I can do one thing, that catch, first catch with pH, one model, then catch with pH plus salinity, that is second model, then I try to make catch plus pH plus salinity turbidity. Okay, so I am adding one parameter, then I see that each their interactions one by one, or maybe multiple all the parameters you can see. So here, what is your dependent variable and what is your independent variable, that is most important. Here my catch is dependent with which parameters, that is my checking. I want to check that which variable is much more important for the catch, either the salinity or the sachet depth or the nutrient or the temperature. So that is way, what is your research question. Based on the research questions you can do for a test. Simple multiple correlation, multiple regression model, or multivariate analysis is also very much important for this kind of analysis, this kind of research questions. Yes, any other questions? So just, yes, let me share you the link for the attendance and name. I just share you in the time. So here is the link I'm sharing, that you typed in your name only on that form. So this is the link, you can click and you can just type down your name for the certificate, proper name. Okay, so this is one thing. And yes, so next I think we'll go for a regression test, simple linear regression to multiple linear regressions. We are going only the linear regressions, we are not going to a non-linear regressions here. So I think you understood the correlations. Code is available here. You can, I told you that you can use your, with your, just first try with that whole code with my data, my dummy data, then you can try with your data and changing the variable, changing your data code data and changing the variable, and then try those things. So here is the, what is the possibilities of different types of graphical multiple. So I have put everything is here, you can try. And different types of test is also there, it's Pearson to Kendall to Sparkman, every test is here. Now go for regressions. So regression theory is, I think, clear. So we'll go for only directly for the analysis. So here I have a data. I'll see which data is there. So here is the data for regressions. I have a data of yield of a particular crop. That yield, whether it is dependent on the height of the plant, or maybe the air length of the plant, or the number of panicles, or is the weight, test weight in the of the whole plant. Okay, so it's the yield is dependent with those multiple variable or not. Okay, so this is the hypothesis. So we'll see that my regression model is, I am assigning that reg, that's that the code, and then the lm is the linear model. So the lm is the code for linear model of regressions, lm. I want to see that whether yield, that is the dependent variable, yield is dependent on the height of the plant or not. Okay, first one. So simple one sample or one mean simple correlation, not a simple regression, not a multiple parameter, multiple regression. So I want to see that yield is dependent with the height of the plant or not. Okay, so I'll run this one, then I will find out the result whether the yield is not or no. So here I will get my regressions analysis. So here it tells me that the whole the regression test is significant, as you find out here. So it tells me yes, it is significant. So the yield of that particular crop is totally depend on the height of the plant. If the height is increased, and if I see the R square value, R square value is also 0.54, sorry, here 0.57 adjusted R square. So this means yes, so it's from this regression is significant. So you can predict the yield from the height of the plant, but that predictions will be 57%. Means I'm confident 57%. So the predictions will be 57% correct. Okay, so but my as my regressions is significant, so I can use these regressions to predict the yield. So how to predict the yield? So that is also we'll see on the down there later on, but I'll show you here. So that is, I told you, equation is y is equal to mx plus c. Y means the dependent variable. So here my y is basically yield that I'm going to predict in putting the x is the height of the plant, and I have a slope and intercepts. What is the slope? This is the 0.09, that is the slope, and intercept is the 6.26. Okay, so and that is the minus negative. So you can use that y plus mx plus c in that equations. You can plot c, x and m. X is, I tell you, the height of the plant is suppose 30 centimeter, then what will be the yield? You can predict that yield from that simple equations, but that predictions will be 57% accurate. Okay, then now go for a Poisson distribution. So there is a non parametric test, or basically non-normal data here we have. So we'll see the Poisson distributions here. I'll try to see what is the type of the data. I have a data of a particular species catch, that is a sardine catch, whether this catch is dependent on the effort, number of boards, and also that CPUE, that's the per effort, catch per effort. Okay, so if the catch per unit effort will be increased, but basically the effort is increased, then CPU increase, and then catch will be increased or not. So, and this data, if you see, it's basically a not a linear data. You can see running a, I think if I run Sapiro, if I run Sapiro test of sardine catch. Okay, so here you will find out the probability value of the Sapiro test is less than 0.05. As I told you earlier, whenever it is less than 0.05 means you have to reject the accept the null hypothesis. Sorry, reject the null hypothesis. So in that case, that data is non-normal. Okay, so even if you see the box plot, whatever it is graphically, you see that sardine catch, that is basically non-normal. So we have to do, for non-normal, we have to do a Poisson distribution GLM model, not an LM model. So here it will be goes to a, here is also you see the histogram of this both the data, then you will find out that whether it is a, suppose this is, so it's not a normal, it's a basically highly skewed data. So even in the box plot you will see it's too much outliner, and the median, it's on the median, not in the mean. So it's even the Sapiro test you will do, all the codes are here, you can run. Then you can run a nonlinear GLM model, that is a Poisson distribution. So family is the family is the, I think, Poisson, yes, family is the Poisson here. Okay, it can be Gaussian or Gaussian for the normal distributions, and Poisson for the non-normal distributions. Okay, so if I run this one, Yes, I'll find out that yes, both the things are highly significant. So catch is depend on the effort. So effort number of boards. Yes, catch is depend on the effort. Okay, so that from these regressions I can say that catch is highly significant for the effort. So if you increase the effort, you can get more catch. Okay. Now I have a binomial distributions. As I told you, binomial means yes or no. So there is a some of the example. You just go through it. Each and everything is written in all the codes and written such a way that everything should be even with the hypothesis also. So binomial distribution is yes or no, male or female. This kind of binomial means two variables I have, yes or no, but it is a ordinal data. Okay, it's not a continuous, or it's not a nominal data. Okay, sorry, or nominal data, not ordinal data. So here is a one of the example of binomial regressions. Binomial regressions, you can run this one. I have one data, I think. Let's see the data of this binomial. Yes, so here is a one of the things that according to gender and exam pass or fail hour of study. Okay, so if you study more, whether you pass or fail, or whether your pass or fail depend on the gender or not, male or female. So that is also dummy variable I have give you in their regression. Okay, so I put 0 and 1 will be male or female. So gender is a one of the factor that can be impacted pass or fail, or the hour of study. Okay, so that will run a binomial model here. Just let me run the whole things. So here that result is says that hour of study is insignificant, but gender does not have any significant. Okay, so if you study more, you will pass. If you study less, you will be fail. But whether you male or female, pass or fail does not make any sense. Okay, so that's a binomial regressions model. Okay, then you can run other things also here, just how to calculate the predictions. Okay, probability of pass, how much percentage of student will pass if they study this much of hour from these regressions, as it is a significant. So I can tell you that how much study you go for 10-hour study, you will pass or fail. Okay, so that is the predictions. Now, one multiple regressions. I have one example here of multiple regressions. Let me see the data. Here is a one data set. It tells us that the milk productions of a cow, of different cow, milk productions, does it depend on the body weight, or dry weight, or the protein intake. So that cow does giving the milk production is depend on the body weight. If the cow is very large in body size, it's the milk will be more or less, or if they are taking more protein on their diet. Okay, so here is the hypothesis is the how the milk production is depend on the body weight or dry matter, or interaction is also there. Body weight plus dry matter both can have a effect on the milk productions. So I have two model. One is without interaction, and one is with interaction. So first model, regression model, is still that the model one, it's still me the linear model. Its milk productions is depend on the body weight plus dry matter of the protein intact, but this is not an interaction. So plus means no interactions. Okay, and multiplications means there is an interaction. So without interaction, I will see that whether both the variables have the impact on the milk production or not. If I get the result here, so regressions models, it's tell you that overall regressions is significant, but body weight is not significant factors. So if the cow is fatty, or cow is not that much less body weight, it does not matter in terms of milk productions. But dry weight or of the protein intact is highly significant in terms of milk productions. If you give high protein diet to the cow, so the milk productions will be increase or increase. Okay, so that is tells you a multiple regressions model without effect. Now we will run, and if you see the R square is 0.87. So if from means if I do predictions from each, so it is I think very good predictions. I give you that 10 kg of protein to the cow every day, so it how much milk it can give it to me. Okay, and if we go for a interaction effect with multiplication, see the interaction effect. So here body weight, as I see, that's a no, but dry weight is also now comes as a no, because whenever you put the interaction effect, that the whole thing is non-significant. Okay, so in that interaction effect means if you have a body weight plus dry protein intact, that is basically both the things will not work together. Okay, so if means if the cow is very high in body weight and you are giving more to protein intact, but it will not gives you a good milk. Okay, so that's why the last one, that the body weight is not an important factor. So that's why I told you that whenever some of the regression in the regression model, some of the variable is not a significant factor, at that time you have to remove. Suppose I have another 2 3 more variables along with the dry matter, suppose is the temperature of the environment, suppose is the cow health, whatever it is, you can add more parameter, then you will find out that some of the parameters is making a non-significant in the test, so then you have to remove. Otherwise that body weight is having, if you make an interaction effect, that body weight does not make any significant of the whole thing. So that means that if the cow is bulky in habit and you thought that if I give a more food to the cow, then it will gives me more milk, that does not. Okay, so it tells you even the interactions, it will be totally non-significant. Okay, so that is one of the important factors of the multiple regression. Then you can run multiple parameters also here, adding one by one. But important factors is that each if any of the variable or independent variable is basically having a problem of the whole thing, so it's better to delete that particular variable from your model. So that's all about the regressions, simple regressions to multiple regression, binomial regression, even the Poisson distributions, mean non-linear regressions, not non-linear, basically the non-normal data, and binomial is there, and also multiple regressions with without interaction and with interactions. Okay, so any questions? If no questions, then we'll go to the last one. That is the chi-square test. Yes.
Hello.
Yes.
Hello. No, meta
Yes.
this meta regression.
Yes.
So how we can apply in ecosystems, sir?
As I told you that each and everything have its own component and own type of analysis. There is a unlimited format of analysis type is there. So meta-analysis is a totally different approach. Meta-analysis. So meta-analysis you can do. That's why I told you that's a different statistics. Is a higher statistics. I'm not going to teach on that or NMDS meta-analysis, PCA, or ANCOVA I'm not teaching here, but those are the advanced analysis, advanced statistics will be a different course out of it. Okay, so meta-analysis is different for the ecosystem service or ecosystem or maybe the other things. But here we are giving very basic statistical test. Okay.
Okay, thank you, sir.
Hmm. Any other questions? So if not, then we'll go to the next. Yes, yes, yes. You can unmute yourself and ask the questions. No problem.
Okay, thank you very much for this wonderful training. But I just wanted to know, for multiple regression, is it the number of input variables that makes it multiple?
Is
I want
it?
to know, is it the number of input variables, the number of the independent variables that make it multiple, or why is it called multiple
Yes, yes,
regression?
yes, 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 yes. Yes, of course. If you have, as I told you, that more than one is called a multiple. Okay, so if the milk productions is depend only in the body weight, so that's a single regressions. Okay, and if you add more parameters, just like a milk production is depend on the body weight, depend on the dry weight, depend on the environmental temperature, depend on the humidity, or different other things, also cow health, whatever it is, that is called multiple. So if you add more independent parameters into your model, that will make more than one, it is multiple.
Okay, thank you very much. But
Okay.
this with effects, without effects, can you throw more light on that, please? With
Yes,
effects,
yes,
without effects.
yes. Effect means whenever you have suppose I tell you this is body weight and dry weight, it is without effect. Okay, here I am not putting plus is the without effect, means they are not interact. Okay, so if you have multiple parameters, you can do a normal adding without effect of each and every one. So that effect is very complex. It is means as I told you, I think I don't know whether it is in ANOVA. I show you that the 2A ANOVA, and if you go to the post hoc test in that one particular, that ANOVA, you will find out the how much is complex in the interaction. So plant D is interacting with calcium, plant C is with this one. So there is all the variables is interacting to each other. So interaction is means the body weight is interact with the dry mass of the protein weight also, as I mentioned you. And if you add more effect, so it will be make more complex model. But one you have to do first a without effect to see that which parameter is making your model a non-significant. Okay, so first you have to run a without effect model, regression model, to see. Suppose if I run here that without effect model, say, see the body weight is making a problem. So if you run without effect, with effect with that body weight which is not a significant, then your might be the whole things will be non-significant. That is we are getting here in the result. So that's why first you have to run a without effect to find out which parameters is basically making a problem in your whole regression model, then delete it. If you have a 5 or 7 multiple parameters, so might be 1 or 2 making me problem, so delete them, then your model will be very strong. If I include them, then the whole interactions will be non-significant. Okay, because that particular effect of body weight or anything, as I told you again and again, the body weight, if you thought that if a bulky cow, if I give you more feed on that cow and it will give me more milk, that does not matter. That is coming out of this result. Okay, so first you have to run a without effect to check the which parameters is problematic, then you can run a interactions. Yes, yes,
Thank you very much.
yes, yes, yes. Questions?
Hello,
Yes, yes,
I have question.
yes.
Thank you first for your presentation. For a mediator, how we deal with a mediator as analysis. So is it considered as variable? Some mediators might affect more than one variable, for more than one variables. So how can we deal it with analysis? Thank you.
If I understand properly, so you are telling about the mediator or something. Yeah. So yes, that will affect a kind of a interaction effect. So some mediator might be enhance my some suppose a reaction. Okay, chemical reaction. Some mediator can be enhance the reactions, or maybe some of the mediator can be decline or the not enhancing the reaction. So that is the things you have to identify from the model that I am telling again and again. Then you have to delete those mediator, which is a problematic. You have to find out from that first one. Then you have to delete it and then run the regression model to get a better result.
Okay, thank you.
Okay, so if you will go to the last chi-square test. Chi-square test is very simple. Everybody knows about it, I think, and everybody is use it. It's very simple. It's nothing but the very simple test. It is called that observed and expected. Okay, what is observed and what is expected. So it is basically goodness of fit, how fit your model is. Okay, so suppose one example, what is the probability of a student ratio, male female ratio in a class. Usually what is my expectations? My expectations in my class, the male female ratio should be 50-50. That is my expectations. Okay, so that is called a chi-square test. It is basically gives you the how goodness of the fit of my expectations. So it is basically deal with the expectations with the observations. But if I go to my class, new class, I see there is only 5 female and 15 male. So that is basically not fit my observe or my expectations. So if I do a chi-square test, it will tell you that it is not significant. So it's my expectations is not valid with my with my observations. So that is called a chi-square test. Once very simple, it is used in basically in observations type of just like one example in biology, in Mendelian genetics, where we are using basically the dihybrid or monohybrid cross. We know the Mendelian genetics 3 is to 1, monohybrid cross, in dihybrid cross 9 is to 3 is to 3 is to 1. So that is basically expected ratio of second generation or first generation between the hybrid cross. Okay, so there is a it's already expectations is already fixed. So you have to check with your observed data whether it is fit with the expectation or not. Okay, so here the null hypothesis is the proportions of the observations are expected at the same or not. Okay, are same. So that is a null hypothesis. Alternative hypothesis are the proportionate observed and expected are not same. Okay, so see, here is one example that I told you, that the chi-square test of a dihybrid cross. So in a dihybrid cross, there is a common ratio is 9 is to 3 is to 3 is to 1 in Mendelian genetics. uh, it's so then in a populations we have seen this is the questions is written here, you can read whenever you get it. And then we have a populations of that particular different genotype of ratio is this. Then we have to predict my of expectations, that 9 is to 3 is to 3 is to 1, and then I can run a chi-square test to see my expectations is same with my observations or not. Okay, so if you run that chi-square test, then you will find out your probability value is 0.7. That means it's more than 0.05, means you have to accept your null hypothesis. It means that the proportions observed and expectations are the same, means whatever the Mendelian genetics tells that 9 is to 3 is to 3 is to 1 will be the ratio of the different genotype in that cross. Yes, it is the same. Okay, so if you see the expectations and observed is 560, 180, 190, 50, and your expectations is almost same, 562, 187, 187, and 62. So that ratio is also 9 is to 3 is to 3 is to 1. So from this chi-square test, you can say that proportion of observations and expected of the genotype of the generation 2 are the same. Okay, so that is a chi-square test. Then I told you the male-female ratio in a classroom. That is also same. You can run a chi-square test whether male-female ratio is 50-50 or not. Is basically expectation is basically 50-50, 0.5 or 0.5. This is my expectations. So you run a chi-square test and you will find out whether this 30-40 or 30-16 is it's not as 50-50. So you see the probability value is 0.01. It's mean that the male female ratio in your class is not as expected. Okay, so this is basically a observed versus expected, and then there is a different other format of chi-square is there. Chi-square test of independence. So this is the chi-square test of goodness of fit, how fit your observations with the expectations. This is called goodness of fit. Another chi-square is basically it tells about the independence. Okay, so whether your that particular variables is independent with the others or not. Okay, so here is one of the example I am showing here. In a water, if you are treated with lime treatment in a pond ecosystem, so treated and untreated. So if there is a disease in a fish, suppose disease in a fish or any aquatic animals, okay, so and then you try to lime treatment, to do the lime treatment to cure of this disease of this particular fish. Okay, so I am doing a lime treatment. So I find out that with the lime treatment, that populations 125 fish is not cured, only 32 fish cured. But in control without treatment, if I don't do the lime treatment, the uncured is 153 and cured is 42. So I want to see that whether lime treatment is effective or not. So my question is that proportion of the carb infections is independent with the lime treatment or dependent on the lime treatment. Okay, so this is my hypothesis and this is my problem. I have to do a cascade test of independence. Then you can run a test and you will find out that whether the lime is effective for that particular disease or microbial disease of that particular fish, it is affected or not. Okay, so if you run the whole things, I think you will find out the result. Yes, 0.01 mean probability value is less than 0.01. That means that lime treatment is affected for this treatment of that particular disease in this for the fish in this aquatic body. Okay, so and you can see the expectations and observations are almost the same, so it is affected. So if you do the lime treatment, the fish will be cured from this disease. So this is chi-square test of test of independency and test of goodness of fit. So that's all about the whole things, I think. So we have finished all kind of test. So if you have more questions, then we can go through the questions. Any questions? So as I told you again, I already sent you the email that I told you again that yes, the course is free, but donations are welcome. You are welcome if you donate, and that whole money will goes for the education for the needy children. Okay. Yes, yes. Someone raise hand for the questions. Yes, yes. Ask.
Thank you, sir, for the session. Sir, in the R, is it possible to make a temperature graph?
Yes, yes. I told you that R is basically till now. But so I have a, frankly speaking, I don't have very wide knowledge about R. It's not possible. It's a very limited knowledge. There is a lot of things, lot of things you can do with us, everything I can say. So you can search in Google what is your problem, what is your idea, and then you can find out the solutions. There is a very good platform that is called GitHub. You can type down in Google GitHub, and you can, there's a forum in the R, also GitHub. You can raise your questions there, and you can find out in Google. There's a lot of resource. R is basically having a huge resource available, from the code to everything, and also video you will find out in YouTube. So it's depend upon your problem. You can ask in the forum, and you can find out in Google of your particular problem. Okay, any more questions? I
Yes.
think I have already shared it. Yes, yes.
Yes. Can we use a PCA for water quality tests?
Yes, yes. Why not? PCA. What I can say, I can say you that yes, water quality test PCA. PCA is basically, it's basically tells you that there is a whether in the component means that they having. Suppose I have just the last yesterday I have give you one example in box plot of the different water area and different water quality. On that model we have run the PCA here. So here it's basically, it tells you that whether they are basically how they are linked or how they are related to each other. So if it tell you two component, with the two component, it's how they're distance from each others. Okay, so not related to each other. Suppose here in that I think in that example yesterday we did it. So for agriculture is totally a different component, and whether if you go for a what is called industrial or this one, industrial and landfill, they are making a different component. Okay, so from running this one I can say that agriculture water quality is totally different or distance from because they are making a landfill and industrial, they are making a one cluster. Okay, agriculture is totally different one cluster, and urbanizations is different cluster. So agriculture have much more and so that's a way you can run water quality analysis, and you can run a PCS, very easy and very simple things. Yes, for yesterday's session, I already shared the YouTube link, and here is also you can find out the YouTube link, and you can also, I have from this YouTube link, you will find out the last session recording, and today's recording when I'll receive from Google, I'll upload it for I'll send it to you in email. Any other questions? From this link, you can, yes, yes, Reem. From this link, you can check the last lecture recording. Yes, yes. Ask if you have any questions. If no questions, then we'll end the session. And as I told you that you will receive the certificate, but it will take time. We have to track the attendance and we have to find out the who have attended the whole session. Then we'll yes, Hafsa. Then we'll upload the. I'll send you the attendance certificate, participation
Hello, sir.
certificate.
Hello,
Yes,
sir. Yeah,
yes,
please. I just wanted to know if we are going to receive the PowerPoint documents too in our mails.
yes, yes. You will receive.
Oh, okay. Thank you very much, sir.
Okay, okay, okay. Anything?
Do you mind to repeat this course?
As I, yeah, it's I can repeat, even I can make a advanced statistic course with the multivariate analysis PCA, and then NMDS or different other advanced statistics nowadays is very essential and everybody is looking for. Yes, I can make it. I'll if I make it, I have a free time. I'll prepare the whole things. Then I'll inform you.
Thank you very much, Dr. Dutta. This is very informative, so insightful.
Okay, thank you. Okay, so if there is no questions, so we are going to end the sessions, and will you will receive the certificate on the time. Okay.